So, greetings, students, and we'll be continuing with morning's class. And over here, we have seen about three criteria. Okay, so three criteria we have seen. So the last criteria, this is the way for reducing your Z bus matrix when it is in the within the same power system, in bus system, that is within the existing Q bus and your reference bus. Okay, so this equation is also called as node elimination technique. So just a minute. So okay, so we'll be continuing, and yeah, now, now the final part is that it is based upon between two existing buses. Okay, so this is a thing. What happens when two buses are there? Okay, and with respect to that, you can take that to be as bus B existing. Okay, so the bus B is in the existing within the in bus system. Okay, followed by the bus Q, which is also within your in bus system, and followed by ZB. Okay, and And for this, how you can form your z bus new means, that is your new value of z bus, how you can form means, so it comes like this. So z bus new should be equal to, so over here you will be having your z bus original. Okay, and now your column and row of your nth node will be like this. So over here it will be z n plus 1. Okay, z n plus 1 into z n plus 1. Okay, so this element we have to find. Okay, for this there's a separate formula. Okay, and after that what you have to do is, here z1p minus z1q, and over here it will be z1, sorry, 2p minus z2q. Okay, and this goes up to znp minus znq. So just a minute. And followed by, over here it will be zp1 p1 minus zq1. Okay, and over here it will be p2 minus zq2, and this extends up to znp, that is zpn minus znq. Okay, so this is the formula through which you can find it. Here the element of n plus 1 column is different. Okay, that is the difference between your pth and the qth bus. Okay, so this is with respect to your column. The same is applicable for your row also. Here the diagonal element is given by the formula z n plus 1 n plus 1 should be equal to zb plus zpp plus zqq. Okay, minus 2 zpq. Okay, so this is the formula for your diagonal element. And here the, if you are following node elimination method, so when the node elimination method comes means, so during the problem you can understand. Now I'll be just saying, uh, if the matrix elements is less than the size of the matrix, then you have to apply for node elimination. So node elimination is nothing but what we have seen in your uh, third criteria. Okay, the third criteria we have seen, right? So the same thing is applicable over here. And over here, how it comes means I'll be writing the formula again. Actual equal to zjk minus zj n plus 1 into zn k divided by zn plus 1 z n plus 1. So this is this formula what we have seen for a Gauss elimination. Okay, so this is what regarding your four criterion. Okay, so now we'll be getting into the problem, so it will be easy for you to understand. Okay, so these are the four criteria. So next we'll be getting into the problem. So is it best problem? Okay, so determine Z bus for system whose reactance diagram is shown below. Okay, and whose impedance value are expressed in per unit representation. Okay, so the diagram goes like this. It consists of three nodes. Okay, it consists of three nodes, 1 and 2, followed by your 3. And now the connection is okay from 1 from 1 to 2, from 2 to 3, followed by your 1 to 3. Okay, and here exists a reference bus. This is your reference bus. Okay, so now the connection is like this. With respect to it is here is one connection, and from your third bus also there is one connection. Okay, so the value of here it is J 1.5. Over here it is J 0.15. Over here it is J 0.3. Over here it is J 0.2, and over J 1.2. Okay, so this is the problem. So for this problem you have to form your Z bus. Okay, they have given your impedance diagram. From the impedance diagram, how we can solve it will be seen. So to form Z bus matrix for given system. Okay, solution. So now how you have to find out means you have to look through your reference bus. Okay, that too from your left to right. Okay, that too from your left to right. You have to see it, and if you are taking into consideration means you have to consider this value. Okay, this value of ZB, which is attached to the particular bus. It's attached to the particular bus, and if you are just segregating and drawing that separately means this is your reference bus. Okay, this is your reference, and this is your first bus, and this first bus is connected to your reference bus through a ZB. Okay, or your reactance of value J 1.2. Okay, J 1.2. And if you're seeing this means this is a reference bus. Okay, this is a new bus. This is a new bus which you are connecting to your reference bus, and hence what happens, this will be coming under the criterion of adding a branch of impedance ZB uh, to the reference bus, okay, from the new bus. That is your first criterion. Okay, that is your first criterion, and as per the first criterion, you are just forming your Z bus now only. Okay, so your this is the initial stage of the formation of your Z bus. So as per this, here there doesn't exist any Z original. So we are forming just the Z new using your Z new you are forming. So this is your ZB new. So what happens? You can there's no Z original, and here exists only one node. This you have to see. So this is very important. How much node you have to check it out. Okay, how much node? So here the node is one. Okay, node is one. So if the node is one, just a minute. ஹலோண்ணா இந்த வந்துட்டாங்கண்ணா கிளம்பிட்டாங்கண்ணா இந்த வந்துட்டாங்க இந்த அப்பா அம்மா அங்கே பக்கத்துலேயே இருக்காங்கண்ணா இந்த வந்துடுவாங்க. நான் இங்கே காலேஜில் இருக்கேன். அப்பா அம்மா அங்கே அடுத்த தெருவில் தான் இருக்காங்க. இந்த வந்துடுவாங்க. அப்படியா? இந்த ஒரு நிமிஷம். இன்வாய்ஸில் இருக்குமாண்ணா? எதில் இருக்குண்ணா? Sorry students, here I got held up. Just wait a minute, I'll be back. So okay, so what you have to see is that this n bus is there, right? Yeah. So here I have left. So you have to check it that the number of node is one. So as it is one, here you will be getting a one cross one matrix. Okay, here you will be getting a one cross one matrix. As per it, the one cross one matrix what will be is the element of this ZB you will be getting. So what you can write directly, you can write J 1.2. Okay, so this is your step one. Okay, of connecting a new bus to your reference bus. Okay, you have connected your new bus to the reference bus. I hope you're clear with this. And I'll be moving to step two. And over here, so you just draw the existing system. You just draw the existing system. So this is your reference. This is your one first bus, and this is your second. This is the existing bus. Now this bus has become an existing bus, and to this bus, you have, as I said, you have to move from your left hand side. So you are moving from your left hand side. So when you are moving from your left hand side, you are coming across the second bus. The next bus is your second bus. Okay. So then you have to connect your second bus to your first bus. And now what happens? You have to put the second bus over here. So this is the new bus. This is the new bus what you are going to connect. Okay. This is the new bus what you are going to connect. And this is of j 0.2. This is our j 0.2. Okay, and now we have to find the z bus, and this, if you're seeing, means this comes under the criteria of new bus attached to a existing bus. So this is the existing bus, so you're connecting a new bus over here. So now this z bus, okay, now this z bus becomes, this is as per your second criteria. Okay, this is as per your second criteria. So here you have to put your z bus original. So this is your z bus original. Okay, this you have to put as such j 1.2. Okay, so after this, uh, so over here you're having two nodes. So here your n value will be 2, so you'll be getting a 2 cross 2 matrix. 2 cross 2 matrix you'll be getting. And over here, as per the what we have seen, here your j value will be added, that is this zb value will be added to this zb value. Okay, these two will be get added up, and this will be j 1.2 plus j 0.2. Okay, this is what we'll be getting. And over here, in order to fill the other elements, the same elements will be repeating over here, j 1.2 and then followed by j 1.2. Okay, you just get clear with these steps. I'll be back within a 2 minute. Okay, now you have to just add the matrix. So now the Z bus matrix what we have built becomes, so it becomes like this. Z bus, it should be equal to the values of this J 1.2. Okay, so this J 1.2, this becomes J 1.2 or by J 1.2, and over here this will be J 1.4. Okay, so this is what with respect to your step 2. Okay, so you completed your step 2. Now we will be moving to your step 3. So in the step 3, so the reference bus, okay, followed by a first bus, followed by a second bus will become your existing buses. Okay, and this will be J 1.2, this will be J 0.2. Okay, now what you are going to do, the same thing what you have considered for the step 2. Okay, we will be adding a new bus step 3 as a new bus. Okay, new 3. Okay, to your existing bus. Okay, and the value is, and the value of this is J 0.15, J 0.15. Okay, and now your Z bus becomes, now your Z bus becomes, okay, so what happened is that the same thing you have to first write your original matrix. This matrix you have to write, this is your original matrix J 1.2. Also here your n value is 3, so you will be getting a 3 cross 3 matrix J 1.2, and here it is J 1.2 followed by J 1.2, J 1.4. Okay, so this is the criteria of second criteria, that is adding a new bus to an existing bus. So now we have these elements get repeated over here. So J 1.2 by J 1.4, and these rows gets repeated here. It will be J 1.2, okay, J 1.4, and over here what happened is that the element, this diagonal element, this last element gets added up with this ZB. So it will be J 1.4 plus J 0.15. Okay, I hope you are getting to understand it. So it is just an addition only. It is easy to form. These kind of Z buses are very easy to form. But the thing is, you have to always cross check that your number of nodes value, you have to cross check always. And now if you are adding means at the step 3, so your Z bus, final Z bus value will be J 1.2, J 1.2, J 1.2. Here it will be J 1.4. So here it will be J 1.2, will be J 1.4, will be J 1.2, it will J 1.4, and over here it will be J 1.55. Okay, we have added. Okay, I hope you got some clear idea. And the next part is you're going to connect. Okay, so step 4, I'll be just drawing the diagram alone, and I'll be just passing with respect to this. Okay, for the step 4, you just see the diagram. So already we have drawn a reference. So first bus we have completed, second bus we have completed, okay. Third bus is there. Third bus also we have integrated, okay. So this goes like this goes like this, and this goes like this. So here it will be J 1.2, here it will be J 0.2, and here it will be uh, J 1.5. Okay. So now you have to connect this system. Okay. So that is uh, connecting connecting. So it is 0.15, 0.15, and over here you have to connect this, that is your J 1.5. Okay, so what happens, this is the structure it looks like. So this is the existing system, this is the reference. So you have to connect existing with the reference. Okay, so here there is no criteria for any new bus. Okay, and okay, so I think I am stopping with respect to this, and okay, I'm having a call. Okay, I'll be, you can just move on. Okay, I'll be just calling you afterwards. I'm having a call, to an important call. Okay, so with this we can finish today's class. So thank you, students.